Alright people, Benjamin here. I'm going to show you what I'm working on. I have a cheap Chinese audio video transmitter for the 1.2 gigahertz band that's supposedly 1.5 watts, but I'm not really sure that it is. It's putting out a little more. Anyway, what I want to do is, I made an earlier video about this antenna that's going to go on the airplane. It is a ground plane antenna. That's going to be going on the airplane like so that way it directs all the signal towards the ground and not up towards the sky. So it's going to be like this on the bottom of the craft, as you saw in the first video. So this antenna was longer than this, about an inch longer, and I cut it way too short. But let me show you how I'm measuring the SWR on this thing to make sure that I don't destroy the transmitter, because if you have a high SWR, not only is it going to overheat your transmitter really fast and potentially cause a fire, you know, wood, stuff like that. Also, it's going to destroy the transmitter. Plus, also, it's going to distort your signal, as well as many other things that I'm not going to get into. But a method of testing it, what I have is, you know, you get your video transmitter. It's connected to a directional coupler and to a dummy load. This is how I'm establishing the baseline. And this little itty bitty glass thing is a 1N82 alpha or 1N82A UHF microwave detector / mixer diode, and I'm just reading the voltage on the meter, and I will show you here if I can do this with one hand. Alright, transmitter's on. Alright, the forward, the power going into it, minus 10 dB, is about 3.8 volts. Okay? Alright, I'll show you the other way. Okay, now this is with the directional coupler, with measuring the reflected, or is coupling minus 10 dB from the load. So, and it's only 0.185 volts-ish. Now that's kind of an arbitrary number, because as you see, this is not the way to set this up. There's RF leaking out like crazy, and it's not really a good idea to keep measuring like that, especially at microwave frequencies. You can burn your eyes. So obviously anything like this is, you want to do these testings in very short iterations at microwave frequencies, because like I said, your eyes are the most sensitive to RF besides your skin. And you know, if you're going to do FPV or whatever kind of transmitter work, you need your eyeballs. Anyway, so if these numbers are anywhere near correct, and if I figured the math out right, the SWR in the dummy load is 1.3 to 1 ish. So like I said, that's not an accurate number. I just need to establish a baseline before messing with the antenna. So, and then when I plugged in the antenna, I disconnected the dummy load, took my coax here, connected it to the directional coupler, and again I established the forward voltage, saw what it was, and then I turned the directional coupler around to what it is now to get the reflected voltage. And you can take the voltage and using using math, or I just use a chart. It says, okay, the voltage is this, that's how much power it is, blah blah blah. And then SWR is just a simple algebra formula for configuring your power, for how much what your SWR is. Anyway, I cut it too short because I kind of forgot when you're dealing with millimeter size frequencies, or I'm sorry, centimeter size, because 1.2 gigahertz is the amateur 23 centimeter band. You know, chipping this thing off 1 millimeter makes a difference. So yeah, I chipped it too short, and honestly I don't like this mini UHF type connector, so I'm going to redo it. And neat experiment though. It's the first time I ever used these. I had these diodes for 10 years or more, and yeah, something like that. Anyway, a fellow ham sent them, and this is kind of cool to test this out. Anyway, as you can see here, I have lots to do, that's for sure. Thanks for watching.